Hello, and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and apologies for being away. I've been a bit ill, but I'm almost back to full health again, I think. So this week we're going to cover some more banking on Clojure. And I hope you're enjoying that pun on there. And today we're going to look at SQL, standard query language for databases. We're going to create some tables and put some data in the database. And then if we get time, we'll try and wire that up to the handlers, although that might be covered next week. Let's see how we go. We'll also have a quick look at provisioning the staging database as well, which is something I had a few little teething troubles with, but just getting a connection string. But we'll get that. We'll show you how I did that as well. There's lots of things I haven't covered yet in terms of the database. So this is a very simplistic approach. But it'll give you like something to build on and actually make this more of a production system over time. Okay, let's see if this all works. That's not what I want. I've been away and things are broken. Laptop stream. Let me just change that. That's the wrong. There we go. Okay. There's Practicalli. There it is. So as usual, all the information is on the website. There's the updates I've been doing for Clojure Together in Q2. And live broadcasts, all separated into nice playlists. There's books. I've been doing a lot of work on the Clojure Web Apps book and also on the Practicalli Clojure book as well. Some interesting stuff there on using Rebel and other data browsers in there as well. So if you can have a look at the using Clojure tools, data browsers, there's some interesting ways to actually go off and inspect and browse the data as well. So you can actually see and explore data, as well as doing that in the REPL. You can also have like a nice visualization of data as well. And I've also got Rebel running with Cider, so I can use that with Spacemax, Emacs, or you can just use it up by itself. Hello for everybody joining. Thank you very much for joining. And of course, if you want to reach out to me, then it's a Practicalli channel on the Clojure in Slack as well. And also there's ways to support and motivate me and keep me going through these challenging times. I appreciate everybody who has contributed. It's very much appreciated. It keeps me going. And I think our numbers on YouTube are getting bigger. So I think we were well over 600 now. I don't know how many we've got now. Let's look. Oh, 662. Oh, getting up to 666. I'll have to celebrate for that. Thank you very much for everybody doing that as well. Helps. Feel free to kind of share any videos that you find very useful. I'll be doing a lot more videos over the next few months. So any feedback on what kind of things you want to see in video form. They won't be the live videos that we're doing here. They'll be kind of more structured and thank you very much. There'll be more structured videos and more specific, whereas the weekend videos are more about experimentation and learning as I learn as well. Okay, we're going to look at web apps. So the Practicalli Web Apps book. Then we've been building up this banking on Clojure. And so we've done quite a lot already. We've got our app server configuration. We've got some handlers there. So we've created some basic handlers to deal with requests. At the moment we're using Composure because it's the kind of simplest, most prevalent routing framework. And but we'll also look at things like Re-it, which is quite interesting as well. So I'll do some sections on that probably in the next in a couple of months' time. Once I've learned how to do it, but it's the Re-it. It takes a nice data-orientated approach. Clojure is very good because it gives you a very specific kind of way to map routes, but they're unidirectional, so you can only go one way, and it's specifically for kind of dealing with HTTP requests. If you want to do anything else, then it's a bit of a blocker. It needs a bit more working around, whereas Re-it is more flexible, but then obviously it's a slightly more learning curve to look at that as well. So we've got a bunch of handlers, we've got continuation integration going, so we've got our couch tests running, we've got our deployment platform pipeline. So we've got a couple of applications running. So we just basically have a local repository, push to GitHub, and it builds our staging environment, and then we can promote that to production. And we've got everything done via Heroku. You've got some unit tests, although I need to do some more unit tests as well. And we've got spec. So we already got the spec from a while ago. We'd create some specs for banking on Clojure, and so we're using this to help us build the schema design. So I'm going to go over the schema design I've got so far for the database. And so we use these specs. As we built up the spec, it gave me an idea about what the data is I want to store, so it was quite a useful experience to do the specs first. I did look for a way to generate specs from the like generate database schemas from the spec, but it seems there are libraries that will actually go the other way. So actually, if you've got a database specification, if you've got an existing database and you want to generate specs for it, there are some libraries to do that as well. So that might be an interesting experiment to look at those. And then we've got the database itself. So we're going to play around with H2 database, which we've got some information in around here, which is our in-memory database. It's nice and simple. And then we're going to also have a quick look at the Postgres database, which is all under this production database as well, so provisioning. So I'll have a quick go through that. We'll provision one for production because I've only got one for staging at the moment. And so the main thing is going to be kind of looking at database tables and then doing some database queries, which I need to fill in, which I'll do that after the broadcast. Okay, feel free to put any questions in there. Thanks for the comments. Thanks for the welcomes back. Hopefully it should be me from now until the end of the year, at least. Okay, so we've got a database. We're going to use an in-memory one. We're going to use migrators at some point, but for now we're just going to get the schema right. It's easier to kind of get the schema right and then put it into migrators, I think, because then you can just rapidly kind of evolve the schema using the REPL. And then when you've got it pretty much close on, you can stick it into migrators as well. So we'll do that in a future broadcast. Using H2 is quite simple. If you recall, we did this before. Yes, we will look at, I haven't looked at data hike as a database. Crux is on my to-do list, but I might look at that after Datomic. So it'll be, the databases are going to cover our H2 for development, Postgres for production, and then we'll compare using this application with Postgres and with Datomic. And then Crux, and I'll have to have a look, see what data hike is as well. But there's quite a lot of different options on databases. There's a whole bunch of things that we can look at as well. So yeah, I'll add these to the list of possible ones we can look at. I've used RocksDB before. It's a really fast database, but you do need to be able to write to the disk really fast as well. And there's also online stuff like Amazon and Redis as well. Cockroach and Yugabyte DB also been mentioned as really performant kind of databases. If you want to squeeze out all the performance from your database, then These are interesting databases to look at, all these three. But we're not quite there yet, so we'll look at that towards the end of the year, I think. So development database H2, we can just basically specify that with a map. And this is a map that's defined in the next JDBC library. So this next JDBC, it recommends using this type of form to define a specification. We look at you can use a JDBC string. We'll look at that again today for the Postgres one. But for now, we're just defining a DB specification, and it's just the driver and the database name. And I think, where is it? No. I did have it. There's a list of, I think it's in my other browser. So the database name here, so the DB type, this uses the name to go and actually do a lookup of the database to find out which driver it should be using. And so we don't actually need to include the driver namespace in our code. Next JDBC will actually go and look that up for us. So it keeps it nice and simple. I think I might have closed that page. Yes. And so then we can define the spec and define a data source. So we just use JDBC, just use this get data source, which is from the next JDBC library, and that will basically create our connection that we can use, and we can then start doing creating database tables and so on. So let's have a look at that in the code. How do we switch onto code? There we go. I've forgotten how to use my computer. It's been so long. There we go. So we've got this file. I'll show you where it is. So we've got in our source tree, Practicalli folder, and inside that there's the banking on Clojure, which is our main Clojure file, and then we've got this database access file, which is just basically putting everything into one file, all the database code at the moment. So I'm looking to split that out at some point. Just have a look. So if we have a look at the namespace design, so to do a little mock-up of the kind of namespace we could work towards. So we've got the application. So this is the banking on Clojure namespace. And it's got the system and routing in there. And it's going to require the middleware and hardware. So it's going to take in the requests. It's going to turn them into request maps. And then we're going to use Composure to do the routing onto the middleware and handlers. So sometimes the routing is just going to send it straight to a handler. Sometimes it'll send it to one or more pieces of middleware. And then the handlers are going to get information if they need it. So if they need to pull information from a database, they're going to run queries and data sources. So I've got this as two separate namespaces, but at the moment I'm actually just using one. And then we'll put all the UI page templates into another namespace. Again, it just keeps the handler code simpler to understand. We abstract away all the kind of details of what the information is going to look like. And some of the actual UI pages will actually be middleware itself, especially like the templates. We can actually convert that into middleware, and so the overall look and feel of the application web page that we're returning can be a middleware template, and it just applies that to every single kind of return response map. Okay, so let's go back to the code. There we go. So we're in database access. And we can get rid of that space PD. There we go. We've got a REPL running, I believe. Let's see. Yes, we've got a REPL running. Cool. So we evaluate namespace. I think I've already evaluated these. So again, we've just got this map, simple map. In Postgres, there's not going to be more information because for Postgres we need a user and username and password. But H2 is nice and simple. You can actually see I've actually created the databases already. So it's actually creating this file called, where is it gone? Oh, there it is, yeah. Banking on Clojure. So it's used the name of the database that we've got here for the name of the database file. And you can actually open this. It's kind of a mixture of binary and text as well. So you can actually see a lot of the system tables as well. You could kind of browse through some of this. So it's not 100% secure, but this is only supposed to be a local database. You're not going to check this in, hopefully, into your GitHub account. So now we've got a data source, then we can run like JDBC queries over that data source. So things like we can create tables. So here we're going to define well, initially I defined this as a function, but then I realized we can just have this as def because we only really want to call this once. We could actually even do a def once kind of thing as well if we were going to reload a lot of these things all the time. Oops. And it's basically this next JDBC executes command, and it basically takes a data source. So that's just using data source generically. So we could improve this by actually having a function and passing in a specific data source. But for now, we're just grabbing the globally shared data source from the def. And then in the vector that we've got here, we've got a string, which is our JDBC syntax, is our JDBC statement. SQL statement, sorry. This is just creating a table called account holders, and then this is the columns that the account holder has. And so what I've decided to do is create 3 tables. So I've got an account holder, I've got accounts, and then I've got an account history. So basically the account history has every record has an account ID, an account number, and sort code, an account name, and current balance, and when it was actually updated. So when that's probably that should be transaction data. I think I copy pasted that too much. There you go. Yeah, I think I just copy pasted that from create table accounts. So basically the idea is that every single transaction goes into kind of the history. So that's really, I guess that should really be transaction history. And so this is just a big long list of all the transactions. And then when we want to specific transactions, they've all got like an account ID. So we can basically just get all of the transactions for a particular account just by doing a simple query on this database. So we don't need to kind of have like foreign keys. So I'm trying to minimize the kind of interconnectedness of these databases. That might be a bit of an over optimization, but it seems fairly simple. So we've got basically here our account history with each history of all the transactions ever made in our bank. and then the accounts, it basically gives a view over that. So we have account number and current balance. So we'd need to have a function that will run over, it will get all the accounts and it will basically generate the current balance and update the accounts table with the current balance. So an account table doesn't, account record doesn't have the full history. It just has the current balance on a particular date. So it's kind of just like normal banks work, especially credit cards. You can see on a credit card, you can see your pending transactions. So if you bought something today, it might not have been applied to your to the credit card. It's kind of a pending value that they're going to apply to your credit card in the next few hours or next few days, and so it's kind of modeling that kind of approach. So more of a batch approach, which is fairly realistic. So because you can have this updated like once a day or once an hour, and banks only have like a guarantee of doing like 2 hours to transfer money between two banks anyway. So there's usually always a gap. Unless you're transferring money between your own accounts, then there's always a kind of a gap. So it does emulate that mode of operation as well, and that would work. So long-term thinking is if we've got Kafka stream or some other message queue pushing in transactions, then the account history gets updated. And then at some point there's a process that will update the table, the accounts table for a particular account. So if somebody wants to view their account, then we'd have a function call that would actually go off and review the account history, look at the accounts table, see when it was last updated, and it could actually pull in all the transactions that were newer and add them to the current balance. And if we had a dispute about the current balance for an account, we've got the full history. We can go back over and we can go and work out, and we can actually rebuild the current balance as well to like double check that it is actually right as well. So we're kind of keeping some transactional history in here. At a later date, we could again keep that in something like Kafka, a Kafka log, or having Datomic as well would probably change the design of this a little bit. Give us a few more features because that's keeping a more of a value over time approach, whereas this is kind of my basic interpretation of how to do that with a simple SQL. Hopefully that made sense. I'm going to try and I'll do a diagram to kind of elaborate on that a little bit more, and it'll probably make sense when we actually get all the code in place as well. So we've got an accounts table, and then quite simply we've got the account holder table, which is just basically built from the Clojure spec that we created. So we've got the account holder and all the essential data. I haven't added all of it. There's a few extra bits we can add in there as well. We might want to do something better with the residential address, but for now it's just a varchar. Yeah, so the SQL is just the name of the column and the type of the column, and then not to forget to put a comma at the end, because if you don't put commas at the end, then you get syntax errors in when you evaluate these as well, which I got a couple of those when I was copy pasting. This is a bit like JSON. I always forget to put the commas at the end because we don't really use the commas and things like that in Clojure. It's very easy to miss them off. Any questions on that? Where are we going? Ooh, 24. Okay. So I created a few helper functions as well. So I kind of like to explore the database a little bit. I created a helper function to go and have a look at the information tables. I never quite know if I actually really need to know this, but sometimes it's useful just to see what's already predefined in a database. So this is a function passing in a data source, and then we're just going to execute a query on that data source. So if I go in and do information tables on a data source, it gives me all the information in a vector. Let's try that again. Let's pretty print that so it's easier to see. Oops. I'm going to have to rename that function because I keep getting it wrong. Let's make that bigger. So this just gives us basically a vector of all the tables, and they're all maps. They're all defined as maps, and it got this auto qualification in front of the maps as well. So if you're really curious, you can go and have a look at all the data in there as well, and there's even the account history table that I've already created. So I've already run those defs, and it's created a file. They're already in the that MDV file that we created for H2. So you only need to create them once. They're not just contained in the REPL's memory. They're actually written to disk as well, written into that file, into the banking on Clojure MVDB file. So they're all in there. So you don't have to recreate everything all the time. But obviously, if you do need to do that, fingers or thumbs. There we go. If you do need to create them, then we can drop the tables as well. And rather than navigate the whole all of the tables in there, we've also created a show schema function. So we pass it the table name, and there's no kind of substitution in Next.jDBC that I could find. So basically use the classic string function, just to join the SQL statement with the value that I'm passing in of table name, and so we evaluate that, and then we can go off and show specific databases. There we go, and then we see so if we've forgotten, if nobody wrote down what the actual design was, we weren't quite sure, we can actually go in and double check to see what's being created in the database as well. There we go. And I think in as we get multiple databases, then I'm going to change these functions, which I've done in another. If you look at the database Postgres one, so what I've actually done is refactor these so they actually take a data source and a table name, and that way we don't actually need that information schema. We can just pass in the different data sources we have. So we have a data source for H2 and a data source for Postgres, and then a table name, and then we don't actually need the information tables because we can just pass in information schema tables into that as well. And so then we just have functions here, function calls. So we pass in the database source, which this one's for Postgres, and this one's for with the table name. There we go. So that simplifies the code a little bit. It also makes it a pure function as well, which is good to use. It's not using any information from outside itself, so it's nice and pure and straightforward, and obviously very deterministic in what it does. Any questions? No, there we go. How are we doing? Oh, halfway through. Oh, that went quicker than I thought. Okay, so we've got those, and then we want to create some queries. So query is just executing another statement. This time we're doing an insert, and then I just need to update this. So we'll do a little bit of live coding. So we're inserting into the contacts. We want to have account ID. So let's say the account ID. Oops, what did I do? There we go. And then we got account number and account sort code. Oops, I just got and account name. And current balance. And last updated last. So those are all the column titles in the oh, that's not context, is it? It's copy paste. So this is the account holder. So in the account holder table, then we've got all these columns we're going to update with values in the right order. So the account ID needs to be, oh, we're just using an auto increment for now, is that right? Oh, that says a UUID. Did I get this right? Let's just check. Live coding, where is it? Queries, there we go. Oh yeah, it is you. Can't read. My brain's going. Let's see. Yes, so we want a UUID. How do we do that? Is it Java util? UUID? Yeah, there it is. Is that it? Yeah, there we go, random ID. I knew it was something like that. There we go. Autocomplete to save the day. There we go. So that generates a UUID as a tag literal. So the hash UUID at the front of it is part of the value. It just helps Clojure identify the string as a specific UUID. So we could put that in there. So we could actually use format to do that. Let's just hard code this for now. Let's do that. So there we go. Why? Boop. So account holder, account number, that's just a int auto increments. Do we need to pass anything for that? I'm not sure. It's been a while since I've done my SQL, so let's just put 1 in and see what it does. There we go. And then comma, oops. We want sort code, so that's a varchar. So let's do, oops, diddly. There we go. So that'll be finish word 010101. We'll just use a simple bar chart. We're not using the dashes in there, so we don't need to save any formatting of the values, just the values themselves. Name, just call it current. And then Current balance. How much money do we want? Let's do 1,000. 1,000. Come on, we're not that skint yet. And then last update date. Can we just do date? Oops. No, what is the date for? How do we do date? I forgot how to do date now. Is it the other way around? Oh, what was it? Java util date. Java.lang. Oh, I don't know. I've forgotten how to do a date. But I'll add that later on. Yeah, that sounds about right. Thanks. A bit of help there. So if we leave the account auto increment, so we go auto. So the account number is an auto increment. So if we just leave the account number out of that for now, and then we don't have to, and then it'll just populate a value for us. Yes, that makes sense. It's been so long since I've done SQL, it feels like I've forgotten how to do it. Forgotten. And I'm going to leave the date for now and think about that a bit more. There we go. And so I can get rid of that comment. So we got current balance, account name, sort code, and ID. And let's see if that works. Oh, invalid number. It just, oh, okay, right. That needs to be a number rather than a string, maybe. Oh, yes, yes. And yeah, I shouldn't put a string in there because it's quotes anyway. So let's try that again. There we go. We put it into the database. Yay! Well, that was good. My cat wants to come and play, but he'll have to wait. And so we've got that in a database, and then we can go off and go and select from context. So select's fairly straightforward. Wow. Queries. And so putting these in their own kind of little sections in case I want to refactor out specific things as well. So if we want to read something, oh, I've already got that. There we go. And so we can go and look at the account. So this is an example of going off and looking at account details. So we'd call this from the handler. We go off and pass a account holder ID, and then we go and select from accounts where the account holder is that. I'm going to do something just to so we want to have a look at what we've just created. Boop. Let's delete that. Boop. Boop. I don't need that in there as well. Oh, it's there. Good thing. Yeah, so we've created an account holder. So let's go and have a look at just create an empty query for now, empty function, and pull in the executes and select that from a account holder. Then if we run that, what did I do? What? Not, did I get that wrong? What did I call it? Did I call it something else? This is a fiddly thing I found with SQL. SQL is, oh, it's account holders. you have to make sure you get all the names right. There's no kind of checking of that as well. So it's account holders, that's the problem. And then, oh yeah, that should really be, I'm hard coding that. Oh, that's not, that's not showing the details in there. That's a bit strange, but should be able to just select from account holders, and it should list that there, and do the same thing for account IDs as well. So there's writing queries as to like basically add data in there as well, and so we'll probably need some kind of helper functions around these to kind of write a whole bunch of data in there. So I'll write some kind of generators to generate a whole bunch of information, and then we'll read them. And yeah, so I've got a batch processing section, so that's where I'll kind of do a lot of the pumping in of data. So I'll do that over the weekend and push it up onto the book. Again, if you've got some suggestions, some nice code you want to share on doing that, then that's always welcome. But it's pretty simple. You can just use, if you're comfortable using SQL statements, you just put that into a vector as a string, and off you go. And you can use substitution by using the this question mark and sort of pass in arguments to the functions that you create, and substitute as well. So it's a bit like using format, or you could use format, the format function, to actually build a string as well. It's not as elegant, so it's kind of nicer to use this approach. And there's some more examples in the next JDBC documentation as well. Did I get that wrong? Oh, yes. See, that's the problem with yes. I didn't insert it into the right table. There we go. Oh, and then I didn't. Yeah, and did I call that? I didn't actually call it either, did I? Maybe I'm not quite 100%. And then account holder ID. Oh, okay, that's the value we should be passing into there, isn't it? So we need to kind of substitute that at some point as well. I'm just going to fake that for now. There we go. Account ID not found. So you have to be quite on your game when you're writing your SQL queries, which I'll try and be a bit later on. So a couple of ways I found to kind of help with this is a more obvious choice is to get a nice tool that will help you do this. So if I just hold on a second, there's this tool here which will called dbeaver or dbeaver. I'm not quite sure which is which. This is a really nice tool for helping you create columns and tables and databases and running queries, and it'll also generate the SQL code for you as well, so you can actually just visually build up the tables, and it does that for specific databases as well. So this is generating code for a Postgres database. So you don't have to remember every single difference between all the different databases. This is a really nice tool for that, and I think I've got that. There's links to that in the book. I think towards the end, I think I've got a reference to that somewhere. Maybe down the bottom here. Boom. Yeah, it's a dbeaver, and it's free. It seems, and it's not crippled by making you buy things just to use different features. It's pretty nice. So I've found so far, but interested to hear if you've got any other DB tools as well. So Next.jdbc is great. Oh, that's the page I was looking for. Next.jdbc is great if you are really happy using SQL queries. Yeah, so this is the bit of code where it actually looks up the database, it uses the DB type, and then it looks up the driver it's going to use as well. So when we want to add the Postgres driver, then it's there, and it gives the namespace of that Postgres driver as well. But back to doing SQL, so you can use dbeaver, and there's another approach to using this. Rather than using SQL directly, there's something called Honey SQL, which is quite nice, and probably something I'd be more comfortable with. So you can actually do selects like this, which is a more Clojure approach to writing your SQL. So it's a bit like using Hiccup for writing HTML. You can write your select statements in Clojure, and it's a lot easier to kind of get the right things. And it's also it'll also name complete, auto-complete things for you as well. So it's a lot easier to get things right. Just having a string, yeah, you just have to be more diligent when you're using SQL strings, that you actually put the right information in there, which I failed to do this morning. So it is really easy to do that, and it's a bit fiddly because you have to kind of then inject values and so on. Whereas Honey SQL is just Clojure, so it's a lot easier to do that. Oh, and there is a format there as well. Okay, that's quite nice. Okay, I've lost my. I think there's any questions. Yeah, dbeaver, I think, yeah, is really useful. A bit of a lifesaver for me. But yeah, I'll write some nice SQL queries. So the plan is to write everything in SQL and then kind of do the same thing in Honey SQL, so you can see that. And there's also some other approaches I'll mention as well. It'd be interesting to see how if we can use Honey with migrators, or if we just need to stick with the SQL statements as well. So have a look at the facilities of migrators as well. So ideally, you'd want to take out as much of the SQL from the code. It's useful in when we're developing the application, we're designing the queries to play around with the SQL. Kind of the schemas in the REPL, so that we can kind of rapidly figure out whether we've got the right schema or not. But then once we've got the right design that we want, then it's nice to kind of package all that up into migrators to actually just manage the deployment of any new changes to the schema. Okay, so we've got 10 minutes. I just wanted to quickly look at provisioning Postgres. So we've been using Heroku to deploy the application, and we can use Heroku to also provision a database, which is quite simple. So if I just go on to heroku.com, and this saves me installing Postgres locally, or trying to figure out, like, building up getting a Docker image, configuring that, and getting it working. I can literally just, with a couple of clicks, I can create a database. So on the staging app, I've already got one. I've created a database already. It's using this Postgres hobby database, so it's actually free. It's not costing me anything. It is limited to 10,000 rows, but I think that's fine for now until my application gets some angel funding. Then I think we can live with the free version for now. And we can go off, and it will. There we go. You can go and see a whole bunch of information about the database as well, how much we're using, how many connections. So we've got 20 connections as well, which is more than I actually need, I think, for now. And we can set up a connection pool for this as well, so we can kind of use the 20 connections efficiently. Yeah, and if you want to know the settings and your password and all those kind of details, are in there, but they're also on the application itself. So the application holds a reference to the database as a database URL, and it's kind of using Heroku's kind of rough format. It's not quite JDBC, but it also adds a JDBC like a JDBC database URL under the covers, so it's a lot easier to kind of get that. So if we have a look at the production database, so we can provision that. Let's go and provision a one for production. So this is our production app. So we can click on that one. We don't have a database. We can just go on and configure add-ons. Type in Postgres. Boom. Select, check we want the free one. Yes, we do. Obviously, in production, we want to be able to upgrade that at some point when we've got funding. But then that's it. That's all you need to do to have a Postgres database. So it's quicker than actually downloading Postgres itself. Never mind installing it. And then we can use that locally as well as in the deployed application as well. So let's have a quick look at that. So we've deployed that, we've created that, and we've got the database configuration. So yeah, it gives you that database URL in this form, which is not JDBC, but it gives you there's a JDBC database URL as part of the build pack. And if you run this command, so we're just using the / just to escape the $sign in the command line. So you just run this on the terminal. So I'm calling the Heroku command line. So you do need to install that tool. And we're getting it to run a command, and it's going to run echo JDBC URL. So it's just like typing echo JDBC database URL on the command line. Heroku run just spins up a new instance, a new separate instance of a particular app, and we're just defining which app it's going to run for us, and then it'll just print out the database URL for us after about 30 seconds. It'll just take a few seconds because it's spinning up a brand new instance. It's not connecting to any existing instance. It's always going to spin up a new instance of the application. So it will take about 30 seconds or so. And then it gives us the results, and then we get this JDBC host port database, and then it's got the separate username and password, which is kind of the classic format of a JDBC connection string, and setting the SSL mode to required. And so then we can use that this environment variable to be able to connect to Postgres. So I did that locally here. So if I just switch over to, oops. So I've got database access Postgres. So basically, it's just created a JDBC database URL on my local machine. So either in your shell, in this case, I just added it to Emacs as an environment variable, and we can just get that using system get-env, and then we could just use that as the data source. So that's another approach, and so that's going to work as is. If we did this for the application we deployed on Heroku, then that's just going to work. But we could also break that down into separate specifications. So we could use we could have a connection. Oops, where did I do that? I think I did. Here we go. So we could have like a yeah, it's more like this one, isn't it? So we can have like a JDBC connection, JDBC username and password, and we can just set those up as a database specification there as well, and so it's very clear what it is. So you can take like several different approaches for configuring a data source, and then it just works just as normal, just as the H2. So that was the kind of fiddly bit I had later on. So I'll kind of document all those different options, and then you just use that as normal. So yeah, so we can then go in and kind of use the database as normal. And what was I going to say? I've forgotten what I was going to say now. Yeah, the main difference is I don't think that's in the SQL. This is where I start to find kind of differences between the SQL using for H2 and the SQL I use for creating a table in Postgres. So I'm going to use dbbeaver to kind of to see if there's like a common set of SQL I can use for both databases, because I'd rather have just one set of SQL statements that works with both databases. So there's a bit of testing to do around that. Yeah, so a lot of the joy and challenges of SQL is coming back to me as I'm doing this. But using that dbbeaver tool just makes it so much easier as well. So it's definitely worth getting this or something like that. Anything else I was going to do? But once you've got the connection string, then you just use it just as you would do it. You can connect to this from the REPL and just use it as you would do in the database. So you would just basically add the database driver for Postgres. So there is a website that just has the latest versions of the Postgres JDBC driver, and then you just put that into your deps.edn file, and off you go. You don't need to add this as a namespace. You don't need to require it into particular things. So that's kind of the nice things about NextJDBC. It keeps it nice and simple. You just refer NextJDBC, and that goes and looks up the relevant namespace to use. As we mentioned in this, can't find it now. There we go. Yeah, so it'll go up and look up. If we use Postgres or Postgres SQL, then it goes off and looks for org Postgres driver, and it's also defining the port for us as well. So it's kind of nice for NextJDBC to kind of manage that for us quite nicely. Yeah. There we go. So we can have a lightweight in-memory process database with H2. We can have a full production grade with a staging and a live environment with Postgres. And hopefully we should have a set of SQL queries that do everything for us. That's what I'm going to work on during the week. And then we tie those up to handlers. So the handlers can simply just call the functions to get information and put information into the database. There's a whole bunch of things about setting up users to do this as well. I haven't touched on that, and providing the right access for each users. But that's all part of the kind of SQL we can generate as well. Ooh. There's something else I was going to mention, but I can't remember what it was now. Yeah. Oh yeah. And so yeah, I'll evolve the kind of namespace design as I kind of refactor the namespace of the application. And I also touched on, actually I don't think I mentioned in the last video, I did some stuff about managing connections. And using basically how connections work. So with Postgres, you're kind of each time it's creating, when you create a new connection, it's going to go to a parent process, and then it'll offload that to a worker process to actually manage the actual SQL query that we're running. So obviously in a kind of, when you've got low traffic going to your database, then this is perfectly fine. It just, you've got like a few connections a few simultaneous connections, it works okay. But if you've got hundreds of simultaneous connections, then like putting up a connection pool is useful. So that's something we can add. And basically, so rather than connecting to the database and spawning off a new connection, then we've got these open connections that we just recycle. And that makes puts less strain on the database, because it's not having to create new connections all the time. It's just recycling things. We're just recycling things in the connection pool. And there's quite a few. So we're not going to use connection pool for H2. We're just going to use that for Postgres. And there's a few things we could use. We can use PG bouncers. Hikari is quite common as well. And there's C3PO, which has an interesting name. And there's some other kind of links there for like tuning Postgres as well. So I'm not going to go into massively too much. I'll probably just provide some references. In doing that, I might find some common things about tuning as we go along. But for the scale of application we're building at the moment, then there's not really much need to do tuning. But putting in a connection pool is a very sensible kind of thing, and it's useful to understand how to do that. Alrighty. Well, I managed to last an hour, so that's good. So again, thank you very much for joining me. If you need to get in touch, then Practicalli channel. There's a lot of stuff to do. If you've got any code suggestions, then feel free to add them to the channel. Your code is probably not going to be any worse than mine, so don't be shy. And yeah, if you've got any comments about what kind of things you want to see over the coming next 3 or 4 months before the end of the year, then let me know. We'll try and see how far we get with the banking on Clojure, get that to a reasonable situation. But we'll also throw in a few kind of coding challenges as well as we go along. I might do that in between the kind of weekly videos. Okay. Right, I'm going to go and have a sit down. But thank you very much for joining us, and hopefully see you next week. Thanks again. Bye bye.